Relationship in circles, page 47-48. Okay, on page 47 we have theorem 1011. Says a tangent and a chord intersect a point on a circle, then the measure of the angle formed is half the measure of the intercepted arc. So here you can see is a chord with a tangent, that this arc here will be half to get that angle. So that's why they have half of AB. Angle 2 would be half of this arc, be half the measure. On theorem 1012 it says, okay, if we have two chords that intersect on the inside of the circle, then the measure is going to be 1/2 the sum of the measures of the intercepted arcs and its vertical angles. So here you can see that angle 1 will be the measure of the arc AB, plus DC would be the measure of angle 1, but you got to take it half of it. And then if you look at angle 2, if that's what's given to you, then opposite of it would be the arc AD, or BC would represent the measure of that angle. But on this particular setup, to make sure you see that when these intersect on the inside, you're adding your two arcs together. Okay, adding your two arcs when your chords intersect on the inside, right there. Very important word. Extremely important, because the next theorem, theorem 13, says, okay, if our lines intersect outside the circle, then the measures formed, it's still going to be half, but it's going to be the difference this time of your arcs. So for the first example, there's actually 3 different cases here. The first one is a secant and a tangent. Here they took the measure of the big arc and subtracted the minor arc inside here to find out the measure of angle 1. On the second case, this was case 1. On case 2, here they actually have 2 tangents that are given to us. And the same concept is taking place, though, is you take the larger arc, PQR, and you subtract the smaller arc, which would be the PR. So there's still subtraction taking place on this theorem. And then if I have 2 secants, this is the third case, 1, 2, 3, would be actually to have 2 secants. And with this one, you still have the arc. Here it has BC, which is a fallacy because we don't have BC here. So let me change this arc here to be a B and a C. And then these arcs cannot be AC. Well, shoot. Let me just go ahead and change that to WZ. They messed up this particular case here. So I take this arc BC, oops, there we go, and subtract the smaller arc that is closest to the measure of angle 1 there to be angle 3. Alright, so you have your 3 different cases here that has a subtraction taking place on every single one of these. It is all being subtracted, and that's because these intersect outside of our circle. Make sure you make that clarification. Okay, on examples. On example 1, it says M is tangent to the circle on both of these. Find the indicated measure. So on this one, we want to find the measure of angle 1, but what is stated. It tells me that this intercepted arc is 132, and this is pulling from the first theorem here that an intercepted arc will be half the measure of that arc. So that means on this I'm going to take the measure of angle 1 will be actually 1/2 of 132. So if I divide that in half, I'll have measure of angle 1 equals 66 degrees, I believe. Okay, but do the same thing here. They want to know the measure of the arc EFD. So they're looking for this arc here. And they give you the actual angle, so the reversal is taking place. If I did the arc to the angle, I divided by 2. Since I'm going from the angle to the arc, that means I'm going to multiply by 2. So the measure of the arc EFD is actually twice that, which will be 220 degrees. Alright, example 2 gives us intersecting chords inside. This is inside. That's very, very important. Inside means that we have to add our arcs. Very, very important. So that I can use my actual formula. So to find x, I'm going to have to take half of my arcs added together. So that means in actuality I'm going to take FJ and add it to GH. Those arcs. So if I replace my values, that'll be 112 plus 140, and then I'll take half of it. Inside my parentheses, that'll be 252, and then I need to take half, which will be 126 degrees, I believe, will be the actual measure of x. Okay. If I look at example 3, here notice this is outside. Outside means we are subtracting. Very, very important. This intersection is outside. So that means I'm looking at my large arc. And then I'm also looking at the smaller arc. Because the formula now is that x will be 1/2 of my large arc, that is JF, minus my smaller arc HF. That is the actual formula. Remember, this one is a subtraction that is taking place. And I always want the larger arc minus the smaller arc, so I'll get a positive answer. If I replace my values, that means I'm going to have 170 minus 72 equals 1/2. Well, let's see. I don't know. 170 minus 72 would be 98. And then if I take half of that, that means x as a degree will be 49 degrees, I believe. Okay, here's your independent practice number 1, or your practice problems number 1. If you'll copy it down and work it, as well as number 2 is here available to you to copy down and work. You may have to pause it to copy it. And then we have example number 3, that you want to find the angle y, and then number 4, that you're actually looking for that little piece right here, this angle. So you can pause it, work it, and then start it again. Okay, for this first one, here's the chord with a tangent. This is the inscribed angle is 120, and they're looking for the arc measure that is out here. So that means I'm going from the angle to the arc. That means I have to use the formula where I multiply and double the size. So the measure of ACB is actually twice that value. When I'm getting larger, that means the measure of ACB is equal to 240 degrees. Alright, number 2. This is intersecting inside. Inside means I am adding. Very, very important. If I look at my 2 arcs, my original formula is 1/2 of my arcs. That would be GH plus FJ arc. That will actually equal my degree, whatever it happens to be. If I fill in my values they give me, they actually give me the degree of 52, and then GH I have is 144, and I don't know what FJ actually is. So this one I have to kind of work backwards on this particular problem. I want to get rid of the 1/2 in this particular problem. So I'm going to go ahead and multiply by 2 on both sides. That means this side is doubling, which gives me 104. These cancel out and I don't have to worry about it. So I have 144 plus x. Uh-oh, I just noticed something. This 52 is pointing right here on that side, so I have to actually change this. Just realized something. 52 is up here. I need to know what this angle actually is. So I'm going to do 180 minus the 52. And that actually gives me 128 degrees is the measure of that angle that I'm actually going to be using. So when I double it, now I get a number I can actually use. That would be 256 instead of the 104. Let me find my whiteout. Almost goofed there. What was this? 256. Okay. Then I'll subtract the 144. And that'll give me 211, I believe, is my x degree. So if I'm looking at this, FJ, that arc measure, is 112 degrees. Okay. Alright, on number 3, this is intersecting outside, so that means I'm dealing with a subtraction problem. If I'm looking at my formula, I know the degree will equal 1/2 of my arcs, FK, minus the smaller arc, which is HJ. So if I'm filling things in, the degree I know is 26 degrees. I have the 1/2. FK, I don't know what it is, it's just a letter Y, minus the smaller one, that is 30. If I treat this like I did before, I want to get rid of this half by multiplying by 2. That goes away. And if I double 26, I should get 52 equals y minus 30. I'm going to add 30 and end up with 82. So FK, that arc, measures 82 degrees for my answer, which is y. Okay, example 4 is a difficult one that requires you to remember right triangles from chapter 7, so you may struggle with this one. Here you notice this is a right angle because this is a tangent. These are two tangents. They tell you that the radius is 4, so from here to here, this is also 4, and this little piece here is 2. That makes this whole distance is 6 on our setup. I'm looking for this angle inside here of this little triangle, which means I'm using my trig ratios. The 4 represents the opposite. The 6 down here represents the hypotenuse. So if you're SOHCAHTOA, this is opposite and hypotenuse, which happens to be the sine. Now I'm looking for the angle, so that means I need to do the inverse of my ratio. So I'm looking at the opposite being 4 over 6 will be the degree of this little part up here on top. Remember, to get the inverse, I have to do second, oops, let me clear all that. Second sine, that gives me the little -1. 4 divided by 6, and close my parentheses, so I have that this top angle here is 41.8. Now, this is also going to be the bottom angle because it is tangents. So this is 4 and this is still 6. So this angle on bottom is also 41.8. So if I double that value times 2, means that C, angle C here, is 83.6 degrees. Now this is important because realize these are intersecting outside, so I know that C is going to be equal to 1/2 this large arc here, which they don't have the third point, but I know is A, minus the smaller arc that is AD. If I know C is 83.6, and then I have the 1/2 of A, I'm looking for this little piece here, the AD. Now I know all the way around my circle is 360, and this little piece will be whatever's left over after A is taken away. So that means that this arc AD is actually an expression of 360 minus A. So I'm going to place that over here because this represents my AD. Now I put that in parentheses because this is an expression that represents this value, and when I distribute this negative inside, this actually becomes A minus 360 plus A inside here. It changes that around, which actually helps me out a great deal. The 1/2, like before, I'm going to multiply by 2 so that is canceled, and then this 83.6 is doubled again. So if I show it multiplied, it is actually 167.2. If I try to simplify this, I have a 1A plus a 1A. It now becomes 2A minus 360 is equal to this 167.2. I'm going to add 360, and that gives me 2.725 is equal to 2A. I'm going to divide by 2. Okay, so I have that plus 360 gives me that value. I'm going to divide it by 2, and it gives me 263.6. So over here, this A, let me write this where you can see it better, 263.6 degrees represents that value. If you got that one right, give yourself a smiley face, because that one was a really difficult type problem.